Good morning, grade 8. We have a new lesson today, chapter 10, lesson 6. The title of the lesson is Theoretical Probability. Theoretical Probability. Objective of this lesson is to determine the theoretical probability of an event and to convert between probabilities and odds. Okay, the first part is to determine the theoretical probability of an event. Okay. When the outcomes in the sample space of an experiment have the same chance of occurring, the outcomes are said to be equally likely. Again, when the outcomes in the same sample space of an experiment have the same chance of occurring, the outcomes are said to be equally likely. Equally likely. Like here, equally likely outcomes. I have here a spinner and I have 4 colors, blue and yellow and red and green. There is the same chance that the spinner will land on any of the colors. There is the same chance that the spinner will land on any of the colors, because each part of each color is equally the same. Each part of each color is equally the same. The part of the yellow is equal to the part of the red, is equal to the part of the green, is equal to the part of the blue. So the spinner can equally comes on any of the parts. But if you look to the example on the right, the blue part is greater, takes greater space in the spinner. So not equally likely outcomes. Not equally likely outcomes. Like, there is a greater chance that the spinner will land on blue than on any other color. Why? Because the blue part is greater than other parts. The blue part is greater than other parts. But in the first example on the left, all the colors have the same space, have the same distance, have the same area. All of them are equally. All of them are equal. But in the right, the blue part is greater, is the greatest part. So there is a greater chance that the spinner will land on blue than on any other color. So here what I will say that not equally likely outcomes. Not equally likely outcomes. Not equally likely outcomes. Erase, please. The girl who drew on the screen, erase, please.
Not me.
Not me. I don't know even how to draw.
Okay. Then the theoretical probability of an event is the ratio of the number of ways the event can occur to the total number of equally likely outcomes. Again, I'm going to read. The theoretical probability of an event is the ratio of the number of ways the event can occur, number of ways can occur to the total number of equally likely outcomes. Okay, girls? So, let me read the chat. Okay, Judy Kurdi. Okay, so, theoretical probability. Theoretical probability equals number of ways the event can occur over the total number of equally likely outcomes. Number of ways the event can occur over the total number of equally likely outcomes. Okay. And experiment in which all outcomes are equally likely is said to be fair. An experiment in which all outcomes are equally likely is said to be fair. Fair, like the one on the left, all the outcomes are equally likely is said to be fair. You can usually assume that experiments involving coins and number cubes are fair. Why? Because number cubes, we have 6 chances. We have 6 chances. And the coin, we have 2 chances. So it is equally likely outcomes. Okay, girls? So it is fair. We call it fair. But the one on the right here, not equally likely outcomes. Okay, girls? It is not fair. Let's solve the first example so we can get the point more.
Teacher,
Yes, I will. Let me first pause the record. Okay, example 1, finding theoretical probability. An experiment consists of rolling a number cube. Find the theoretical probability of each outcome. Number cube has 6 sides and each side has a number. Okay, so number 1, 1A, rolling a 3. So I have only one outcome that I will get 3. So what is the theoretical probability that I will get 3? Number of ways the event can occur over the total number of equally likely outcomes. Rolling a 3, I will get 3. So how many outcomes I will get? Only, which is 3. So it is 1. And the total number of equally likely outcomes is 6. So the theoretical probability is 1 over 6, which is, if I want to write it as decimal, it will be 0.16. If I want to write it as percents, it is 6 2/3%. Again, girls, I don't want you to get confused between the theoretical probability and the experimental probability. The theoretical probability is how many outcomes over the total outcomes. How many outcomes over the total outcomes. But the experimental probability, number of times the event occurs over the number of trials. Again, experimental probability. How many outcomes? Rolling a 3. So I have one outcome, which is 3, over the number of outcomes. How many outcomes I can get in a cube? 6. So I will write 1 over 6. Let's go to the second page to read the second example. Rolling a number that is greater than 3. In the cube, what are the numbers that are greater than 3? 4, 5, and 6. What are the numbers that are greater than 3? I have 4, I have 5, I have 6. So how many outcomes I can get greater than 3? How many outcomes I can get greater than 3? 1, 2, 3. How many outcomes? 1, 2, 3 outcomes. So I'm going to write 3 over the total number of equally likely outcomes. How many outcomes are there in the cube? I have 6 outcomes. Okay, girls? Outcomes. So I will write 3 over 6. When I will simplify it, it will be 1 over 2. Let's solve this one. 1A, rolling an even number. Rolling an even number. Even number on the cube. It is 2, it is 4, it is 6. So how many outcomes I have? I have 3 outcomes. Over how many? Over 6. If I will simplify it, it will be 1 over 2, divide up and down by 3. Okay, this one, rolling a multiple of 3. Multiple of 3, from numbers 1 to 6. I am in the same rolling a number cube. Multiple of 3. I have 3 and I have 6. So how many do I have? I have 2 outcomes from 6. So I have 1/2. Okay, girls. So let's watch now this video.
We can actually compute the theoretical probability of certain outcomes by taking a look at, well, the information we know about the actual event itself. Now, it turns out that theoretical probability in general is really hard to find, but in special cases, when in fact all possible outcomes are equally likely, we can actually create a ratio that gives us the theoretical probability. And here's the formula for it. It's actually pretty easy and maybe even a little bit intuitive. The theoretical probability of a particular event is equal to the number of ways that the event can occur, and we look at that divided by the total number of equally likely outcomes. So again, we have to be in a situation where all outcomes are equally likely, and then we look at this ratio, number of ways the event can occur divided by the total number of equally likely ways, and that produces the theoretical probability. Let's take a look at an example and see if this actually makes a bit of sense. So here's the example I want us to take a look at. Let's imagine that we roll a fair number cube. Now, here's some notation that I want us to think about. The actual event is going to be the rolling of a number cube and seeing the number. So by P of 5, that means what's the theoretical probability of doing this experiment and seeing 5? So the probability of seeing a 5 is equal to, and now we have to compute it using this formulation, well, the number of ways the event can occur. How many different ways can we see a 5 from this regular number cube? Well, only one way. It's got to land that face up. So there's 1 out of the 6 equally likely possibilities. And so here we see the probability is 1/6, which equals 16 2/3%. So you can think of it as a fraction or as a percent. What about this one? The probability that what we roll is less than 3. Well, how would we figure that out? Well, what are the number of ways the event can occur? Well, there's several ways. I can roll either a 1 or I could roll a 2. Either one of those ways would yield success with respect to this particular event. So there's 2 out of the 6 possibilities. So we see 2 out of 6, which equals 1/3. So that's the probability, or as a percent, 33 1/3%. So you can see that's a lot more likely than it is to roll a 5. So rolling a 1 or a 2 is more likely than just rolling a 5, which I think makes a little bit of sense because there's 2 options here, right? There's 2 options. So in fact, it's not that surprising. Finally, what's the probability of rolling this number cube and actually seeing a number that's bigger than 7? Well, what's the total number of ways that can happen? Well, there's no way that can happen, so there's 0 ways that could happen. This equals 0 divided by 6, which is 0, and that equals 0%. So not likely at all, but we are able to produce the theoretical probabilities for these different events, and in fact, for other events as well.
Girls, let's go back to our book. Okay. I will start from this part. From this table, the green one. When you toss a coin, there are 2 possible outcomes, heads or tails. Yes? Yes, it's clear. When you toss a coin, there are 2 possible outcomes, heads or tails. The table below shows the theoretical probabilities and experimental probability results of tossing a coin 10 times. The same coin 10 times. Here the experimental probability and the theoretical probabilities. Okay? Theoretical probability 1 over 2 and 1 over 2. Why? Because it is one time it will be head, one time it will be tail. Because I don't have except head or tail. Experimental probability 3 over 10 and 7 over 10. After I toss the coin 10 times, I got 3 times I got head from the 10 times, and 7 times I got tail out of the 10 times. Again, the experimental probability. The experimental probability shows me the outcomes. So after tossing 10 times, from the 10 times, 3 times I got head. And from the other, the 10 is 3 and 7. 3 times I got head and 7 times I got tail. Okay? 3 over 10 plus 7 over 10 is 10 over 10, which is equal to 1. Okay, girls? Which means that when I toss 10 times the coin, I will get head or I will get tail, right? 3 times out of 10, I got head, and 7 times out of 10, I got tail. When I add them together, they will give me 1. And the theoretical probability, the heads is 1 over 2, and the tail is 1 over 2. This table shows the difference between the experimental and the theoretical. Theoretical, 1 over 2, because I can get head and I can get tail. The two choices are whether it is head or tail. So whether it is head, the first choice is head and the second choice is tail. I don't have any more choices. So the first choice is head, which is 1 choice from the 2, 1 over 2. And the second choice is tail, which is 1 choice from the 2. So the theoretical probabilities is talking about the number of choices, the number of outcomes. But the experimental probabilities is talking about the outcomes that I got. The theoretical probability is talking about the number of outcomes. Let's read here. The sum of the probability of heads and the probability of tails is 1 or 100%. This is because it is certain that one of the two outcomes will always occur. P event happening plus P event not happening is equal to 1. Yes, Tala?
Now, teacher, when you mean, in the experimental probability, for example, 3 over 10, 7 over 10, we add them together, like 3 plus 7.
This table is just showing that. This table is just explaining, not a way of answering. It is just explaining. It is just a way of explanation. But you will not, just wait, Tala, just wait. Let me complete this part and explain the rule and answer example 2. And then I will go back to your question. Okay, Tala?
Okay.
I have a rule here. P of event happening plus P of event not happening is equal to 1. How? I will read this part. The complement of an event is all the outcomes in the sample spaces that are not included in the event. For example, if I have a number Q, okay, and when I took it, okay, I got 3. The other numbers are complement. Okay, the other numbers are complement. So the complement of an event is all the outcomes in the sample space that are not included in the event. The sum of the probabilities of an event and its complement is 1 or 100% because the event will either happen or not happen. Two events are complementary events. Two events are complementary events if the sum of their probabilities equals 1. And if one event occurs, if and only if the other doesn't, one event will happen because if another event will not happen. So P of event plus P of complement of event is equal to 1. Which means P of event happening plus P of event not happening is equal to 1. One of event will happen because another event will not happen. An event will happen because one of the other events will not happen. So event happening plus event will not happening is equal to 1 or equal to 100%. Event happening plus event not happening is equal to 1 or 100%. I can call it P of event plus P of complement event plus complement event is not happening is equal to 1. Tala, give me a question.
Yes, teacher. In the example you gave us for 3
Number
over
cube?
10.
For the coin.
Yes. And now if we want to, for example, here we add. Can we, for example, subtract or multiply or divide, or it's only for addition?
No, it's only adding because they are showing you that the event happening and the event that are not happening will give you 1. I cannot subtract and I cannot multiply. It's just to show you that the event happening and the event that are not happening, their sum will be 1. Their sum will be 1. Okay? Only I want to reach that their sum will be 1. I want to reach this point only. Equals to 1. Okay? Equals to 1. Okay?
Okay.
Welcome, dear. I'm replying to your chat. Okay, example 2. Finding probability by using the complement. The weather forecaster predicts a 20% chance of snow. The weather forecaster predicts a 20% chance of snow. There is a 20% that there will be snow. What is the probability that it will not snow? It will not snow. So we have a rule here that P of snow, that P of not snow is equal to 100%. So P of snow plus P of not snow, P represents probability. So P of snow plus P of not snow is equal to 100%. So I want to know P of not snow. So 20 plus a number equals to 100. How I will get this number? I will subtract 20 from two sides, so I will get 80. So the percent of the probability of not snow, it is 80%. Okay, girls? Again, there is a forecaster that predicts 20% of chance of snow. What is the probability that it will not snow? I have a rule here that P of event plus P of complement event is not happening is equal to 1 or 100%. Or 100%. 1 or 100%. So since I have here the problem as percent, so I'm going to use it as 100%. So 20% plus P of not snow equals to 100%. So I'm going to subtract 20% from two sides. So I will get 80. The 20% will cancel the negative 20. 100 minus 20 is 80%. Okay, girls? We're going to continue our lesson tomorrow, and we're going to watch more videos tomorrow, inshallah. Okay, girls, I hope you got the point, and see you tomorrow, inshallah. Okay, girls, thank you so much for interacting, and see you tomorrow.